So remember I said datasets are kind of taking over Spark, and you should be using datasets instead of RDDs anytime it makes sense because it is a faster implementation. It can actually optimize SQL queries a little bit better than it can with plain old RDD operations. And it can also represent data more efficiently when things are represented in a structured format. So as an example, let's go back to that most popular movies example we did a while ago in the course. And instead of using RDDs, we're going to use a dataset to actually get the answer that we want, to find the most popular movies out of the movie lens data. So let's take a look at how that works. I've gone ahead and imported the popular movies datasets.scala script into my project. So hit pause and go take care of that if you'd like to follow along. And I certainly encourage you to do so. So let's take a look. So the first part of the script is actually unchanged from the popular movies.scala example. We just have this little function here that loads up the movie ID to movie names map. Nothing new there, so let's not talk about that too much. And now, remember, we're trying to deal with structured data now. We're dealing with data sets, so we need to define the structure of that data. So here we're defining a movie case class that only contains one thing, the movie ID. So remember, all we're doing is trying to count up the grand total number of times each movie was rated. And to do that, the only information we really need is the movie ID. We can map that to movie names at the end when we're printing out the final results. We don't care about the ratings. We don't care about the timestamps. We don't care about each individual user. All we care about is the movie ID for this problem. So let's plow ahead here. We're going to create a Spark session, just like we did in the past two examples, instead of a Spark context. That will let us do SQL operations more easily. We're going to call this popular movies, local every core. Remember again, this config line is only needed on Windows, and you do need to have a C temp folder on Windows for this to work. You need that line with Windows. It won't work without it. If you're not on Windows, it won't work with it. So if you're not on Windows, remember to get rid of that line. And once we have our Spark session object, what we're going to do here is load up our u.data, the movie ratings data from the movie lens data set. Doing it the old-fashioned way through the Spark context here because that is unstructured. But again, if we had JSON data or an actual database to import this data from in a natively structured format, we could do this straight into a data set without this intermediate step. We could just say spark.read.json, for example, to suck in JSON data. But since this isn't structured, we're going to have to structure it ourselves before we can turn it into a data set. That's what we're doing here. We're calling map on that raw data. And what we're going to do is take that tab delimited data, extract the second field, which is the movie ID, and convert that to an integer. So we're going to create a new movie object based on that movie case class, passing it in the movie ID that we extract from each line of that input data. So what we're left with is an RDD called lines, which is an RDD of movie objects, okay? And each movie object just contains a single column, the movie ID. So we can import spark.implicits. That will allow us to convert that lines RDD into a movies data set. So at this point, we've converted our RDD to a data set of movie objects. And with that data set, we can do SQL-ish things. So here's where things get interesting. Now remember back when we solved this problem with RDDs, we had to kind of jump through some hoops. We had to first map things to movie IDs and the value number 1. So we had key value RDDs. And then we used a reduce operation to actually count up all of those counts for each individual movie. But we can do that just using a SQL styles query here, right here. So this is a much more simple one-liner sort of a thing here. We don't have to do any like crazy stuff of mapping things to key values where the value is 1 and doing a reduce. We can just do things in a more intuitive SQL format here. So let's take a look at what's going on here. We're taking our movies data set and we're going to group it by movie ID. So that does a group by movie ID and a count. So what that's going to do is add a new column to my data set called count. That is the count of how many times each unique movie ID appears, which is exactly what we want. And it's just a very, very intuitive, very natural, very common thing to do in SQL. But using map and reduce, it's a little bit more difficult. So this is a good example of where a SQL-style approach to a problem is a lot simpler. And we can go beyond that. We can actually order our results using order by in descending count. So we're going to take the count field, order it in descending order. So in what we had to do in like multiple steps before, we can do in one line of code here. We're going to group up all of our movies by movie ID, count them all up, order them in descending order by count, and then cache the results so we can issue queries on that. So at this point, we should have a data set that looks like this, where it's movie ID and count, where the count is descending. And we're just going to show the top 20 results just to get that intermediate feel. Then to make it human readable, we're going to grab the top 10, load up our movie ID to movie name map, and just apply that map as we print out the final results. So we'll iterate through each of the top 10 results. We will take the movie names, extracting each result as an integer, and then print out the movie name for each one. Finally, remember to stop the session when we're done, and that's all there is to it. So there you have it. Again, the key point here is that what took multiple steps and a little bit of weirdness with an RDD is actually just a one-line operation here using Spark SQL and datasets. So pretty neat stuff. Let's see if it works. Go to run configurations. I've already created a popular movies datasets run configuration, so hit pause and go take care of that if you need to. And let's run it. 100,000 ratings, so it does need to chug through that a little bit. Optimizing that query as we go, and there we have it. So here we have that intermediate output here where we're looking at the top 20 results here of movie ID and count. So that's what that one line of code gave us at the end there. And then our little bit of code there to make it human readable. Sure enough, the #1 film in the Movie Lens dataset is still Star Wars, and followed by Contact, Fargo, and then Return to the Jedi. So this dataset's showing its age from the 1990s, but it is accurate information. So there you have it. Very cool stuff. So that's a good example of how using datasets can actually make life a little bit easier for certain types of problems. And we've gone back and taken an old RDD solution to a problem and made a dataset solution to the problem instead. And I would challenge you to do the same thing. Go back to a different example from earlier in the course and see if you can actually convert it from an RDD-based solution into a dataset solution using the capabilities of Spark SQL. It would be a very good exercise for you. We've done some other simple examples earlier in the course. See if you can use the power of datasets to actually make it a little bit simpler, a little bit more intuitive. So that's my challenge to you. All right, and there you have it, Spark SQL in action. Very important stuff again. Again, the whole Spark world seems to be moving in the direction of more Spark SQL powered features all across all aspects of Spark. So very important you understand this going forward. All right, hope that made sense. Let's move on.